And I mean, when this coin hits, I just initialize my weight to 0.
Okay.
So I have like kind of a 30% chance for a weight to be initialized to 0, that we don't have any connection between two nodes.
Well, that's pretty good.
You find it pretty big?
Yeah, I like it. I mean, I
okay. Okay, I see. Yeah, I think that's pretty a reasonable number.
Yeah.
So of course we can change that. We can think about maybe, getting it also inside this config screen, how big the bias should be. Something between 0 and 100%. It's all possible. Yeah.
Yeah, that's good.
Okay, but for now, I would just move on. And basically, the next we have genetic algorithm settings. So genetic algorithm, as we all know, it has a mutation step, and for the mutation step, we have mutation rate. Then we have expected fraction of pairs that will mate across all possible distinct pairs. It's basically this mating probability. I indicated explicitly just to understand which number exactly do we look at here. So basically we take all pairs and all distinct pairs, meaning that we kind of take, we take this binomial coefficient and divide it through 2 to get really distinct pairs where we we don't count pairs of 2 same individuals twice bidirectionally. We just take one pair of them and count it as it. Right, and then we look across all the pairs, and I still have this flipping coin, and if the coin hits with the probability of this mating rate, then I just made 2 vehicles, 2 brains to be more exact. I will show you later how I do it in the code. Right now we will just move on. I would just show what happens.
Oh, so there's like a fraction of pairs that'll mate. So, like, if it's within that significance, or, well, I don't know what they call it, but, like, then you would reproduce. So they just have a probability of mating. And then...
Exactly.
Right.
Yes. Right now they have the probability of mating.
Yeah.
Well, reproducibility is the other topic we should, of course, discuss. That's right now, I would just... show how it's done. Well, of course, reproducibility is pretty hard here. I mean, I'm throwing the coin.
Well, I mean, it's going to be like stochastic, but it's like, is it? I guess the first question is the framework reasonable? I think it is. I mean, that's basically how it's going to work. I mean, you're going to have, that's how it would work in a genetic algorithm or in nature, where you'd have like, there's a probability that some mutation occurs, and then a probability of mating, random mating, or whatever. In this case, it's just pairs. And then you have, so you have all these parameters. And of course, if you change them, it's going to look different. But, I mean, basically, you want to have, you want to be able to, one thing you might do once you get this working is actually prepare a curve. And that's something you might want to do for the INCF presentation, is to prepare a curve for different parameter values. Like, if I start out at a mutation rate of 0.001 and I go up to 0.05 or 0.01 or 0.1, then this is the curve for maybe like mating or something. I mean, that's a way you can actually test for reproducibility. It should give you like some sort of performance curve that you can evaluate.
So it's basically this card that I have in Trello. I should be showing it now. It's called hyperparameter optimization, and of course it's on my record. Okay. Yeah, sure.
Good.
That would be something scientific in this simulation. I mean, and it's really important. So I'm going after it.
Yeah.
That's true.
So how do you plan to visualize this? We talked about that last week a little bit.
I will show you how do I do my visualization now. So basically you see the genetic algorithm settings. Like, we can also set this setting as default, so that on the next run we have the same parameters as we have it now. and then we kick off with the simulation. And that's basically a screen how it is right now. So you see this stupid bug of vehicles getting off the world limits. It's still not fixed. I don't know why. It's really a strange thing to me, because I should have, I will show you quickly in the code. I should have this false repulsion function defined in the vehicle itself. So right, so on each time tick, we have this kind of update speed calls, which calculates new speed based on effects from effectors from the world, this world object so-called. And then we also have this false repulsion, right? So in this adjusted speed, I use repulse from walls on the pure speed. And in this repulse from walls, you can see I should be changing the speed with this repulse function from left, from right, so basically from all four sides of my screen, of my world. And this repulse function is, yeah, as you can see, it's an absolute value of 1 through absolute value of distance through c. And c is some constant. I basically introduced it to, I don't know, like something like 100, so that we have, you know, when we are, what it means when we are like 100 pixels away from the wall, repulsion should kick in and move the vehicle away from the wall. So, for instance, from the downside, it should be moving in this direction. From the right side, it should be moving in the left direction. Right, and I've even debugged this thing, and it looks like speed is changing with this, but still, like, they're escaping. I've tried out many ways. I've tried out many functions that you can think of. So not only hyperbolic function, but also some other cases like some quadratic function. I've tried logarithm. You know, the absolute value. I've exploited this feature that logarithm goes into the negative, like that it has a limit of minus infinity when it comes closer to 0. So I've just put an absolute value, and then kind of goes up to infinity when you're really close to the wall. Then of course you can also introduce the constants and say like, okay, when you're really some c points from the wall, repulsion kicks in. So you can also do it with other functions. I've tried that. Didn't like logarithm that well because, well, it had some mathematical issues and it had some issues of scalability and calculation. So yeah, I would be fixing it. I just don't know how, to be honest. Like I would need to debug basically more, because right now it looks just ideally. So it shouldn't be no repulsion. It should be repulsion.
Yeah. Yeah, I don't know. I mean, that looks good so far. Just so you debug that part, and it would be so you have. So let's walk through it again. You have the first part is the interface that you showed me, and that was done in Kotlin. You prepared the little dialog box for inputting.
It's not like let me just continue with showing the dialog box. I got a little bit wayward. I will just complete that, and then we can of course talk about other things.
Okay.
So all right, what we also have, we now, as I reported, we have this genetic algorithm thing. Right. So of course, each of these vehicles, it has its own brain, which I can't visualize now. The only thing that we know about vehicle when we click on it, it's its current speed and speed in previous tick. So that we know, like, I just implemented it to debug basically this wall repulsion. Somehow it didn't go yet, but I'm on it. So I'm using this information to debug how vehicles are moving and how they're getting repulsed from the wall they're heading towards. Yes, but of course, as we can think of, I would later be able to implement a brain visualization here when we click on the vehicle, and then we kind of close it, this nice fragment, it's called fragment in generative fixed paradigm. When we close this fragment, you see the simulation continues. So answering your question, how do I plan to implement something like PR curve or maybe some other metrics? I would pretty much do exactly that. I would just open a new fragment, you know, like just like this, but it would be there on the whole duration of the simulation, and it would just show us some changes in some metrics we would like to know about.
Yeah.
That's basically also, I think, that was implemented in Simbrain. So how Jeff Yoshimi sees that. And I pretty much like the idea. So, you know, you kind of have this, like, you have this big world, and then you also have some metrics, so you can switch through windows. You can leap through them, just look at this, look at that, and yeah, just seeing the information to like, it's pretty cool.
Yeah. So I go back to the first part. So, like, what is implemented, actually, what is implemented in Simbrain and what is not? Like,
Yeah, that's kind of a question. So what's implemented in Simbrain? They have really good cognitive science models, as far as I could understand with my expert eyes. So they've implemented, for instance, they've implemented some Hopfield networks. They've implemented some other models, you know, just some stuff from the literature, and just how it should be theoretically be calculated. Right? What's the downside? It's basically the scalability of the whole thing. So, you know, like I've launched the agent simulation. They have kind of an you know, also something with gustatory and maybe some smell effects. So they have kind of simulation where you have like this mouse moving towards the cheese. And it's basically pretty much like Braitenberg Vehicles, right? So this mouse could be seen as a as some conscious robot moving towards its senses. So it's being affected by the cheese, and then it puts its motors on and just moves towards it. But the problem is, even with one agent, Simbrain still shows some underframing. So it has a very slow frame rate on it. And I've implemented my own simulation just because, well, Simbrain didn't look for me that way that it could be scalable up to the, you know, to the count of vehicles we need. So if we're speaking about 100 vehicles, 1,000 vehicles, something like that, I doubt that Simbrain would be the right choice to implement this kind of big stuff. So they are really focused more on the scientific side, and you know, maybe looking at some models, but they are not focused on, you know, fast render, maybe some features, some. Well, they have some graphics, of course. They have some measurements. They have some plots that they are showing, as I said. But for instance, they don't have any PR curve. So I would basically need to implement the same, just doing it in Java, and add it to not really scalable simulation of the Simbrain, and where I don't know just whether it could host 100 vehicles, for instance. Right. Yes, so that's what's implemented in Simbrain, and that's why I did my own simulation, my own credit using it.
I mean, I wouldn't really worry a lot about like scalability right now, anyways. Like, I mean, if it were like more convenient to do it at a smaller scale, because I mean, really, there's the scientific aspect of, I mean, you don't need huge sample sizes. You just need like a population. So I mean, going up to like 1,000 vehicles, I mean, that would be something maybe to do later, or, you know, in an extension of it. But I guess what you're saying is that Simbrain would allow you to handle a certain number of vehicles, so you would have to like re-implement everything to scale it up, or could it just be scaled up with like, you know, like a Simbrain base basically, and then you'd have to do more work to scale it up?
I think I would need to go out of the Simbrain base to scale it up.
Okay.
That's what I've seen. Well, one reason for that is that they use this Java AVT library, which is basically becoming outdated. PTLink. That's why, this one, like
okay.
Java AVT. It's not the most modern pick right now. So maybe partly because of that, partly because of just it's pretty modulable, but still, at all means, I would need to go far beyond this Simbrain and Java AVT package to be able to scale it up even to 10 agents. So that's what it's about, right? So I of course understand. I'm not launching the simulation with some kind of thousands of agents, no, of course.
Right.
But still, like, we need at least 10 of them, to be able to have some optimization space, some randomized search that makes sense in this whole big parameter space. And for that, I don't think Simbrain would be able to do it.
So you have, let's go through the sort of what you have here. You showed
right. So the last thing, that was a small information screen where we can just take a look on the current simulation state. Like it pretty much is JavaFX properties. It gets fetched just in real time. So it's pretty implementable here in this library. Right, and of course, the most important aspect, what we all go for, is that when I'm clicking the right button, pop, we have the first epoch, and you see vehicles got selected.
Okay.
So we have much less of them. If you look how many we have 5 now out of 22. Right, because of this selection rate, I have 2 selection. I have aleatory selection, and I have just lucky ones who get selected, no matter how good they were. And so I just run the epoch now, and it gets visualized just in click. That's what I have. We can go back, we just can go further. So for instance, we get to the second epoch, 3rd, 4th, 5th, 9th, 10th. We see some vehicle gets born, I guess, or mutated, basically. Yeah. I guess it's rather mutation, right? So it just changed its place, and now it's moving away from the wall, maybe because of the wall repulsion, just on the based on world object effects, right? And we can switch it like that. It was kind of hell of a work to get it running without any exceptions, because there were several things like, I don't know, rendering of this thread, that, like some collisions, maybe some synchronized, unsynchronized accession of the same objects and stuff. But I got through it, and now we can just do it like a charm.
Well, one caveat about small populations, though, you'll need a higher mutation rate in general. It depends on the population size. There are a lot of issues with like population size and mutation rate that you might have to investigate, because you generally, when you have a larger population size and you have a low mutation rate, you get mutations in the population. It's at a lower rate, but you get more of them in general. So when you're selecting, you're selecting from, you're going to get a little bit more diversity to select from. If you have like 5 or 6 and you have a low mutation rate, then you might end up in a local minima pretty quickly. So I don't know again, in terms of scaling up, now that I think about it, it's actually a trade-off. You may want to have larger population sizes if it's like an imperative to have a low mutation rate, something that you can, to have really some exploratory power. I don't know what it's going to look like in practice. I'm just thinking in terms of what theory should predict in terms of population size. But I mean, I'm just letting you know that there are going to be some things that you're going to run into issues in trying to sort of optimize everything.
Yeah, sure. Of course, I will think about it, and it's basically what's next on the agenda. That's I and maybe we think about what metrics do we implement and what do we look at, and how we're going to evaluate the whole thing. So once again, I would just say what was happening out there now.
Okay.
We can even make a simulation bigger just for fun, like say 100. Frame rate could be the same, and you said that we can make it 1% probability. Right, so now they're 100.
Yeah.
Guys, what's happening out there?
Oh. Z.
So yeah.
Oh, I guess. Do you have any thoughts on what Stefan has presented? Like, do you have any feedback for him? What did you think of his approach? So he was showing us what he has so far that's implemented. So he has the sort of the dialog box where you can enter in parameter values. He has this interface where you can visualize things, and then you have you have that thing. Yeah, you can investigate each agent. So Jesse has a comment here. Oh, it's very interesting. Gives me some ideas to look into. Yeah, I mean,
look into it.
Yeah, I mean, I guess he wants to just think about how you've done things.
Thank you.
Yeah. Yeah, I think this is good. I think it's a lot of progress in the right direction. I'm going to point out that next week, I hope next week, we have someone else joining the group. He was someone who did a presentation, or he did a proposal for GSOC and he didn't get selected. And then he did a summer internship, and now he's done with the internship. And he actually, during the application period, he did a lot of really interesting work with vehicles. He created a simulation, sort of like what you have, but it wasn't like the same thing. He was using a different approach, and he had developed like a simulation for vehicles in an environment. But that's as far as he got. So he's interested in developing what he was doing in the application a little bit more.
Mm-hmm.
So we'll talk to him more about that. So Z actually has some comment here. I remember you talked about the wall. How about letting the vehicle continue on the other side when it hits the wall? So instead of repulsion, just basically letting it explore freely.
Oh. Yeah, that could be an idea, by the way. That would even extend the world and maybe get some interesting ideas. Yeah, thank you, Z. I will look into it. I will even write it in my Trello board. Maybe I would implement it this way. Maybe it would also be somewhat more easy to implement than this stuff, which is really a lot of bugs in it.
Yeah.
All right.
So by that you mean what he means by going beyond the wall? I assume is you have the wall that's enclosing a bunch of sensory targets, right? That's what those black dots were. Or?
I'm sorry.
What were the black dots? They were
So the black dots are world objects.
Objects, and so they were attracting. They were supposed to be attracted or repelled by the objects, or.
It could be in different ways. We have. I would maybe show the screen once again, just to show it in the code. Just a sec. Here it is. So basically, when I'm constructing the vehicle, I have this class of sensors. I also have factory vehicles, and what I'm doing now, I'm setting sensors to the one polarity. One polarity means that that they should be attracted by both objects. So now it's fraction, but still we can change polarity to -1, and then of course the vehicle would be repulsed.
Okay.
Yeah.
So, but we have we have those black dots and we have the boundary here. And the original thinking is that the vehicles would hit the boundary and they'd bounce off and then go back to maybe one of these black targets. But what Ziyi is suggesting is that the vehicle can just wander off, so it could be very far from a black dot. And
that could be. That's an idea worth investigating, I think.
So because I wonder if you could select for that as well as for being attracted or repelled by a black dot. I mean, I don't know. I mean, it's because if you think, why is it going over there? It seems like maybe it's just exploring that space. Maybe it'll come back, or maybe it'll get selected against. But what that might suggest is that you actually might have a population that doesn't really have any preference for any sort of sensory thing.
Mm-hmm. Yeah, right. I should look for it more close.
Well, I mean, I don't know. So those are just things to think about, I think, in general terms. Now that you have the environment up and running, but I'm glad to see that you've gotten that far on it. So, and like I said, we do have someone else coming in next week, hopefully. So, I'll introduce him and everything. And he did some interesting simulations on just the environment like that, where, he has vehicles running around an environment. And I can't remember exactly what his hook was for that. Like they were doing something special. Because there were a couple of simulations I found online of Braitenberg Vehicles when I was first sort of proposing this project to Google. And they weren't really operational. Like some of them were dead animations. There was one, but it wasn't very good. So there's actually value in actually just creating a simulation of the vehicles.
So that's also right. That's the second thing I would like to discuss, of course, is where exactly do we like to head with the simulation, right? So I have the skeleton now. And I have kind of more or less correct, rightly implemented nearly all these aspects that we have in the proposal, right? So I have this kind of plain Braitenberg vehicle simulation. Then I have the brain of vehicles also simulated, and the construction of these brains. And then I've also implemented the genetic algorithm, right, up to the moment. So we basically have all that. And the next question is, of course, what should be, to which target exactly should we move so that it's interesting for the community? And that it really is valuable for the scientists. That will be, of course, the main question. The main question I'm asking myself now in the last time. I would just finish with the questions. I also have these 3 questions that I would like to discuss. So basically, if you have any ideas, I would really welcome some feedback on it. So there are 3 things. First, of course, what we also said about the PR curve and stuff like that, is what plots would we like to see there? Which information is really valuable for us in this Braitenberg vehicle simulation? Which metrics would we like to look at? It's basically, we are not limited here really because of Kotlin. Well, because of this really cool binding between Kotlin and R. So basically I can just do normal R plots, which I know how to do. So we kind of have a freedom here, right? We can just pick graphics, whatever it needs. Just the point is, the question is really like, which graphics would we like to pick? Which plots would we like to visualize? Which information would we like to look at? The second question is data export and persistence. So as you've seen now, when I'm kind of switching to the next epoch here, I lose the previous epoch. So I can go left, I can go back now. How it's implemented, how I've implemented this. You know, just of some memory constraints, not to consume much of it. But and I mean, when we've ran the simulation now, it's basically over. So it doesn't have any export now. It doesn't have anything like, you know, like going back, like just some exportable data. But of course, I've been trying to, and I've thought about implementing it. And the question is now, which export and data persistence would we really want to, if any? So would we like something, you know, maybe just some ideas of mine was, you know, to export the state of the simulation in some concrete epoch, or maybe going back to, you know, to the first epoch when we are in the second epoch, something like that.
Okay.
Some data persistence and export. And the third one, yeah, it's basically what I've talked about before. It's maybe the most important one, is like what we basically want to look at. What we, like, I guess we have a, after the bugs are fixed, we have a ability to do the simulation correctly now, and the question is, what exactly would we like to investigate there?
Okay. Yeah.
That's
So the one thing you didn't show me, or that we didn't discuss, is kind of like visualizing the brain, or did we already talk about that?
We did. I'm on it.
Oh, okay, so that's coming like later.
Yeah.
Okay, so I mean, I'm just thinking, like, what could we? So I mean, in terms of saving the data, it's usually just like a matter of summary statistics and things like that. But it's, you know, I don't know what you can actually record and save too. There might be some interesting information in the, like, movement patterns, like to be able to track its movement in the environment at different points in time. So you know where it is relative to, like, maybe some of the other vehicles. You know, I don't know. Yeah, I don't know what it'll actually. Is there a way, like? Well, I guess you'd be programming in, like, you could program in these features, I guess.
Of course, sure.
So you would just be able to say, yeah, so we need to, I guess, come up with a list on that in terms of, but usually it's like summary statistics, but I'm also thinking, like, there are other, like, information about, there's probably more information about the environment that we can, like, sort of program into it. So, I mean, like, maybe I'll come up with a list of things that would be, I think, from perspective of someone using it, would be good to have.
That would be great. That's exactly what I'm looking for right now. Because, you know, still, it's, of course, it would be nice if somebody could use this afterwards. And we would make some, you know, some community, something good for the community.
Yeah. And then I think the idea of doing plots in R is a good one. I think having a good, you know, I was actually thinking about how to visualize stuff, and I was going back to things like Plotly and some of the other, like, open source plot programs. So there's Plotly, and there's a couple others, and, like, that are like R, Java compliant. So, like, I think that's good that we have something that's, you know, in either R or R and Python compliant. I think, you know, something that, not necessarily Plotly, but something along those lines. And I think that's what you're talking about with, like, Kotlin and R, maybe a little bit different, but as long as it's able to be plotted in R, I guess it's pretty good.
Yeah, because R is known for its perfect and really good front-end visualization. techniques and abilities.
Yeah.
That's, of course, the best peak that you can have.
Yeah. And then in terms of the kind of questions we'd like to investigate, I think we'll leave that for a little bit later. Like, we'll have more discussions. Actually, I think maybe it's worth everyone thinking about it. Like, what kinds of, now that you've seen Stefan's platform and then also Ziyi's platform, what kinds of questions do you think we might be able to investigate with something like this? I mean, I can give you some answers, but I want to see what you guys think. Like, what kinds of things do you think would be good? And think about not only in terms of just, how it works, but like, I'd like to know how the brain develops or the brain actually works when it's doing this thing X. Maybe it's like going after some attractant in the environment. Maybe it's exploring its environment. In mice, they do a lot of stuff with spatial cognition. And they actually, they have these experiments where you put the mouse, in a maze and you give it some stimulus and it goes to the stimulus, but you can also have it explore the environment. So they have this one assay called the Morris Water Maze, where they take a rodent and they put it in a pool of water, and there's a platform. And the idea is that you'll have the platform in different places, and the rodent will swim around and explore and try to find the platform and get on it. But then the thing that people are interested in is not like if the rodent can find the platform as fast as it can, but what does it explore? How does it explore the environment as it's trying to find the platform? Does it just go there? Like, does it recognize it and just go right there? Or do they explore around? Do they have behaviors that help them do that? There's a whole literature on this. And, so the idea there is not, whether it's the most efficient path to a resource, but it's like, what is it doing to find its way to that place? The exploration might be very important. And so those are kind of things we might be able to ask of something like this. That's something that we can then put into the program, to allow people to do that.
Yeah, sure. Of course.
Okay, so Ziyi and Jesse, do you have any other comments about this? We have to do the board really quickly before we go. Okay, the exploration literature. Jesse is asking about it. I can provide some links about that. Oh, yeah. So thank you, Jesse. So he liked it very much. He said it was great to see the presentation.
Thank you, Jesse.
Okay. Ziyi, do you have any additional thoughts? Okay. Why don't we do the board real quick? So let me open this up. I'll put in the link in the chat for the board. All right, and if you go to the link and you go to projects, and there's the board group meetings review, and now we're in, and we have a bunch of things that are done now, so that's good. We have a bunch of things in progress. So the first one is number 31. This is something actually Jesse put in the board, so thank you. Research agent mapping, perception, and representation of environmental space and their resources. So what are your thoughts on that? Okay. So we'll just, this looks like it's doing some reading, doing some planning, so that's good. We'll just leave that in progress. Find conference funding through professional organization We discussed that with Stefan. Share resources and implementation ideas. That's number 4. So I guess we're talking a little bit about that. We've been talking a little bit about that. And we'll continue to talk about that. Like I said, we have a new person coming in. He already has some environment, like Braitenberg Vehicles in the environment simulation worked out, but he never did the developmental part. So that might be something we'll share as well. Create Trello board with tasks. I'll just put that in done. Although I guess keep checking the board. Let me make another.
Sure, the board will be updated regularly.
Okay.
So put initials all I have there and to have an overview.
All right. I just wanted to put a new note. Check Stefan's Trello board, and I'll make that I'll assign that to myself, so that we have a good note here on that. Okay, and then that we can actually maybe if we could pull the most salient points to the GitHub board. If it's missing, that would be good. I did that a couple times, but I don't know which ones are most pressing to you, Stefan. So if you have something that you want to.
Sure. I will fetch the issues where I want, especially where I want the opinion of the group to the Trello or to the GitHub board.
Okay. Let's see. Maybe I'll put that up there. Find data references for GitHub repository. Dataset references number 15. I'm still working on that. Visualization of networks. So that's still something in progress. Do you have any thoughts about that? Or, I don't know. Well, I talked to you about some of the reference resources a little bit, like Network X and things like that, but I'm still working on a list of resources. So, but I guess when we get to that point, we can really kind of get into a discussion about it. Community evaluation. Actually, I think that was what we just did. So that's done, at least for Stefan.
Yeah.
Develop way to evaluate movement to cues generated by network. And that was for Z. Do you have any comments on that, Z? Oh, okay. So this is the topic is develop way to evaluate movement to cues generated by network. It's issue number 27. I think it was like when you were doing the simulation or during your presentation, we talked about the movement aspect of it. I think that's what that issue has to do with. So it's working on the movement part of that model. Okay, you're thinking about drawing the distribution. Okay. Distribution of preferences during the simulation. Okay. I'll update the card with the with just what you told me here. So we'll just keep it in the issue, and then when you have it worked out, you can present it, or you can give us an update on it. So I updated the number 27 issue. Number 26, find a means to represent sparse matrices with no compression. Did you just show us your solution to that, Stefan?
Oh yes, I haven't yet done it.
Oh, okay.
I mean, it's still kind of good scalable without even sparse matrices representation. So as you've seen, it runs smooth. I can switch to epoch without any problem. So that's why I would do it on the pen. When I really see that we have some scalability issues, I would go and implement sparse matrices. But right now, I just don't need it.
Yeah, I think that's probably good, because it could give. If you don't need it right now, and
exactly.
It's giving you good results.
Mm-hmm. Yeah.
I think the concern there was that it might be a problem, but it didn't seem to be. So then we have a couple left in to do. We have work on grammar and coding. I think that was like something that we put aside. Create a list of visualization tools and solutions. That's still in progress, or to do. Defining a fitness function in the context of behavior. That's still out in the future, so that's coming up. Discuss relevant scientific questions. Let's put that in progress, and that was something that Stefan asked about for his project. And I think it would be good to, again, have maybe a conversation on Slack, or maybe in one of the meeting, maybe next week in the meeting. Just some really, it doesn't have to be a focused scientific question. Just has to be something you're curious about, or you think, given what you're seeing in the meetings, what might be plausible to ask about, how to something we can solve with Braitenberg Vehicles, or even address with Braitenberg Vehicles. So it doesn't have to be super refined. Just bring your questions, or Jesse. Yeah, that would be good, just to have a couple of things just to bring up, and then we can work them out and see if they're plausible. And so I put that in progress. And then I think review Holland's paradigm, that's been set aside for now. So before we go, are there any issues we want to put on the board for next time? Or for the next couple weeks, maybe?
I would update the board myself when I kind of able to formulate the issues so that we all understand.
Okay, that's good.
Yeah. That's fine.
Jesse or Z, do you have anything else to add to that? The board, or? Okay. All right. Vehicle interaction or potential communication. Okay. Yeah, we haven't talked about that too much. All we've had is the proximity sensors, and there's a lot of work on social robotics, where people have a bunch of robots and they put them in teams, and that's actually a very important part of that field. It's figuring out how the robots communicate amongst one another. So they'll do, they'll deploy the robots in a team. They have to do something, and there's of course work on social insects, different things that social insects do, like swarming or building nests or something, and they have very intricate patterns of interaction, like rules. They work together in different ways, and people have applied this to robotics. So in robotics, you can actually sort of implement rules. It's a blank slate in terms of what the robots are doing when they come out of the box, but then you have to actually design all the interaction rules from scratch, and that's a big challenge, and I think that's a good place to look if you're interested in that. those two areas of the literature: social insects and social robotics. But we'll talk more about that later. Okay, so any other questions? Yeah, welcome. All right. Thanks, Z, for your interest in that as well. So, okay, we'll meet next week. And like I said, next week we'll have a new member joining us, hopefully. And we'll talk then. So anyone, if you want to present something or if you have any ideas, you're free to do so next week. You can just let me know like a day ahead of time or something, and we'll set aside some time in the meeting for it. And, all right, guys, talk to you later. Have a good week.
You too. Thank you. Have a good week, guys.
You too.
Bye-bye.
Bye. Yeah, bye, Jesse. Bye, Z.